Welcome. We're going to do a few examples of inequalities. So if we have this one where we have y is negative, so in an inequality that would show that y needs to be less than 0. And then graphically that could be shown in two different ways, parenthesis or open circle. Those are both when our inequality is just only less than. And then we can also write that as an interval notation where the parenthesis means we're going from negative infinity, so interval goes from left to right. It's a little snapshot of the graph itself. So we do our lowest number on the graph, which in this case is negative infinity. So from lowest to highest, the highest one on the graph is 0. Okay, so for interval, just keep in mind it needs to go from left to right, just like you're reading from left to right on the graph. And then less than, or here a parenthesis would be we're not including 0. And here we're also not including infinity because you give me infinity and I could give you infinity minus 1. That's really not a place we can go sit on the graph. So we just have a convention that we use a parenthesis for infinity. Okay, moving on. Z is greater than 3, so Z greater than 3 graphically. We could do open circle or a parenthesis, and then interval notation, everything greater than, not including 3. And then set builder is another thing that you need to be able to read and understand. So that would be, it's the set of all Z such that Z is greater than 3. So the goal here is to be able to translate from English into an algebraic expression with expressions involving inequalities. Okay, let's do the next one. B is at most 6. So B can be equal to 6 at most. So it can't be 7. It just has to be the upper bound there is 6. So here we're at 6. We could include 6 in everything smaller. And a bracket means you're including the number. So a bracket and a closed circle mean the same thing. So the interval notation, I always use parenthesis for negative or positive infinity. And then we go to 6 since we include that. We have this equal here, so then we get to use our bracket. And W is positive. So if we're at 0, it can't be 0. 0 isn't positive or negative, it just is 0. Okay, so it's everything in between here. It's positive, and it can be less than or equal to 14. So that's what the graph would look like. Interval notation goes from smallest number to largest number. And a parenthesis for, because it has to be positive, it's greater than 0. Bracket, because it can be equal to 14. Okay, moving on. So our goal here is just to be able to go back and forth between English and mathematical expressions. So we're given some information. We have that A is less than 0, so A is negative, and C is also negative. But B is greater than 0, so B is positive. So now I have A times B. So A, we decided that's negative, and B is positive. So for example, if you had something like negative 3 times positive 10, that whole answer would be negative. So the entire thing here is negative. Okay, the opposite of A. So the opposite of a negative, opposite of negative 3, right? That would be positive 3. So this is positive. B minus A. So we have B is negative. No, wait, sorry. B is positive. And then we have minus a negative. So example, sometimes it's nice just to see an example. You can just give yourself an example. So a positive, so it would be like 10 minus a negative. And that's just this idea that we have here. Minus a negative is the same thing as the opposite of a negative. So that would end up being positive plus the opposite of negative, which is positive plus positive. So the whole thing is positive. Okay, moving on. So our goal is to be able to translate between English and math. So here's some math symbols that we need to know. The curly Q brackets, that is the set of, so it lists different numbers. So for example, here, if I have the set of just 1 and 3, that little collection I'm going to call collection A. Now B, that is containing two numbers, 1 and 5. So I'll call that one B. And then C is separate. It just has 0, 2, and 4. So is 2 in A, this little backwards E crossed out, it means is not an element. This one is it an element? Is it contained within that list of numbers that is A? And it's not, so no. Now this is kind of like a weird looking N. So that is the intersection. That means contained within both. That's the and then the kind of strange looking U, that's the or in math. And or is really either or. That's really what it means in English. And means and at the same time. Okay, so let's look at this one. Find the numbers that are A and B. So they're contained within A, and at the same time, they're also part of B. So there's only one number there. 1. Okay, now this one is saying find the numbers that are part of A or either or part of B. If you're a part of A, you're invited to our party. If you're part of B, you're invited to our party. So you've got us all coming here, right? We've got 1, 3, and 5. Now let's look at the ones where we have, this is our and, so they're part of A and at the same time. Part of C. So there's nothing. And then we can write that as the set of with nothing in it, or we can write that just with a 0. And in math, that is called the null set. Okay, let's do a few more of these. So we have B or C. Well, let's get a graph here of what B would look like. Okay, B is everything less than 5. There's 5. Okay, so that's B. And C is just going between -1 and 6. Okay, so this is C. So we're going between -1, but it's not including it, so I'm going to have an open circle. And then we're going to 6, and I can include that. Okay, so the union is our or. Okay, if you're part of B, you're included. And if you're part of C, you're included. So everybody gets to come. So that would be everything that is less than 6. So it would be from -infinity to 6, right? Because here, what's shaded from this line is everything less than, but not including 5. But then what's shaded on the green line, that's from 6 and everything below that, including 5. Now this one is much harder to to get invited to this party, much more exclusive, because you have to be invited to both. So here we have only what's got double shade. So we have going from, but not including -1, and going up to 5. Okay, moving on to absolute value. Let's translate this sentence. The distance from x to 5 is at most 3. Wow. Okay, if it's hard to think about, it is often useful to come up with either an example or a picture. So the distance from x to 5, so I'm just going to say here's 5. The distance is at most 3. 1, 2, 3. So x could be 5.1. X could be 6, because the distance between whatever number x is and 5 just has to be anything less than 3, right? It's contained within there. So it can go up to 8. It can go down 1, 2, 3. So it could go down to 2. Any of these numbers. So I'm going to let x be represented by shade, because it's all those infinite numbers that would make that sentence true. And then putting that into a mathematical sentence. So the distance, that's a subtraction problem between x and 5, but distance is a positive number. It's just the space between those two numbers. So that needs to be absolute value. And so that space between those two numbers, that distance there, can be equal to 3 or less than 3. Okay, let's try this one. X is at least 2 units from pi. So here's pi, at least 2 units. Okay, so this is about 3.14 at pi. So 2 units up would be about 5.14. Okay, so this is pi plus 2. This is pi minus 2, so that would be at, what, 1.14. And so it has to be at least, so it can be there or anything bigger than that. Okay, so again, that's a distance problem. So I find the difference between my pi and my 2, but since it's distance, it needs to be positive. And then that distance there has to be greater than or equal to 2. Okay, so absolute value is all about distance. So let's just evaluate a few of these. Okay, here this means the absolute value of -4 and -6. So that would be -10, and then absolute value is positive. Right, and if we looked at what, why is that so far? Well, -4 is way back. 1, 2, 3, 4, 5, 6. What's the difference between those two numbers, right? 10 units. Okay, let's look at this one. What's the distance between here? Well, we can approximate it. This would be about 3.14 minus 6, and that's about -2.86, and so then since it is absolute value, that would end up being positive 2.86. And notice it's the opposite of our subtraction problem, because what we ended up with in here is negative. And so, right, this right in here is negative, and absolute value changes the sign. So this is the opposite of the negative to get it to be positive. So you can look in there and think, is that positive or negative? Since this whole thing is negative, absolute value would change its sign. So it would be the opposite of that, whatever we get for the exact answer there. So this is the exact answer. And that's what we're looking for on these problems. Okay, so absolute value, if what comes out is positive, then the absolute value of a positive number is positive. So that's if A is, well, absolute value of 0 is also 0. So if A is greater than or equal to 0. But if what comes out is negative, then our result is the opposite of that, because that would turn it into a positive answer. Okay, let's move on. So here, we don't know what x is worth. So we don't know whether we're in this situation where the result is positive and we can just say what went into absolute value is what comes out of absolute value. Or are we in this situation where what comes out of absolute value is the opposite of what we put in? It really depends whether what's in there, the input was positive. This is when x is positive. Okay, or if what we put in, there is negative, 3 minus x, if that was negative, then we have to find that then the result, once you take that comes out of absolute value, it would be the opposite of that to give us a positive output. Okay, so it really just depends. So what we're going to do is just do a little bit of work. It's going to be the exact same as what went in if it was 0 or anything greater than 0. And it's going to need to be the opposite if what is our input into absolute value is negative. So that happens when 3 minus x is less than 0. Okay, so then we just do a quick little bit of algebra. Just solve for x here, subtracting x from, or 3 from both sides, dividing by -1. X is less than or equal to 3. Just remember to flip the direction of the inequality when you divide or multiply by a negative. Okay, so what comes out of absolute value is the same as what went in. That happens when x is less than 3. Okay, but if x is greater than 3, right, we would subtract 3 from both sides, dividing through by a negative. That would happen when x is greater than 3. Sometimes it's easier just to think of some examples here. Okay, so for example, if we had some little number, like let's say that x equals, for example, 1. Okay, so then we would have 3 minus 1. That would be the absolute value of 2, which is positive. So what the expression is positive. So what comes out is the same as what went in. Okay, but that's different if we have something where x is a larger number. So for example, if I had x is equal to, say, 10, then I would have absolute value of 3 minus this big number. That would be the absolute value of -7, and what comes out is not the same as what went in. Since it was negative, what's coming out is positive, which is just the opposite of the negative. Okay, so using the definition here, we can say, okay, there's two things that happen. If what went in, this 3 minus 4x, if that's positive, then what comes out is the same as what comes as your input. Input and output of absolute value are the same. Okay, so that happens only when the input is greater than or equal to 0. Okay, or it's the opposite. Where it happened here, if what went in there is negative, then you have to take the opposite of that to make it positive. And that happens when our input is negative, so less than 0. Okay, and then you can just simplify this a little bit, just simplify those inequalities. So we have two answers, two things that can happen. It's either the same as the input or the opposite. Okay, but let's just simplify that inequality just a tiny bit here. So what do we have? 3 minus 4x greater than or equal to 0, subtracting 3 from both sides, and dividing through by a -4. flip your direction, so it would be less than or equal to 3/4. So x less than or equal to 3/4 or x greater than 3/4, right? If we had 3 minus 4x is negative, subtracting 3 from both sides and then dividing by a negative would change the direction of that inequality. Okay, so that is the answer we're looking for.